We can define the slope of a curve at a specific point, point A, as the limit as h goes to 0 of f of a plus h minus f of a divided by h, provided this limit exists, where h is the horizontal distance between point A and point B. Also, the tangent line to the curve will be the line y equals mx plus b through point A with this slope. Example 1, looking at y equals x squared, let's find the equation of the tangent to the curve at a given point, 2, 4. Then graph the curve and the tangent together. By taking the definition of the slope of the tangent, we can do slope is equal to the limit as h goes to 0, a plus h squared minus a squared all over h. Since we're looking at a specific point, 2, 4, we can take the x-coordinate, the 2, and we can plug that in for the a. So limit as h goes to 0, where the x-coordinate is 2, so 2 plus h squared minus 2 squared all over h. Then we can expand the 2 plus h squared, and we will get 4 plus 4h plus h squared minus 4 all over h. If I combine like terms, the 4 and the negative 4 will cancel. I can't substitute in 0 for h yet. I could factor an h out of the top, where we will have h times 4 plus h by factoring out the h over the h. Cancel the h's. Slope will equal to 4 plus 0. Slope is equal to 4. Let's use the slope is equal to 4 now and put that into the equation of a line, y equals 4x plus b. Need to know the y-intercept of the tangent. Since the point that it goes through is 2, 4, let's substitute in a 4 for the y and a 2 for the x and solve. Get negative 4 is equal to b. Put that all together in a single equation now. The slope is 4, the y-intercept is negative 4. The equation for my tangent line, y equals 4x minus 4. Now if we pull up GeoGebra and graph this, I already have the function 1/2 x squared graphed, so let's change this to just x squared. Let's do the limit as h goes to 0. Let's move a to 2, 4. Got a's location 2, 4. Got an estimate of the tangent line from this GeoGebra graph. That y equals 4x minus 4. Same thing that we calculated by hand a minute ago. Find an equation for the tangent to the curve at a given point, then graph the curve and tangent together. Example 2, y equals x cubed plus 2. Following the definition of slope, slope is equal to the limit as h goes to 0. Since a is the x-coordinate of the given point, we can go ahead and plug in a 1 for a here and here. Limit as h goes to 0 all over h. Okay, after expanding the 1 plus h cubed, we come up with 1 plus 3h plus 3h squared plus h cubed. Bring down 2 minus 1 minus 2. This is all over our h. Let's see if we can't cancel out some like terms. 1 and a minus 1 is 0. 2 minus 2 is 0. What's left can be factored. I can pull an h to the front. H times 3 plus 3h plus h squared all over h. The limit as h goes to 0. If I cancel out the h and the h, then we do a substitution. 0 in for h and h. We'll get 3 plus 3 times 0 plus 0 squared, which our slope would just simplify to 3. Put that in the y equals mx plus b form. Looking at the given point, 1, 3, where 3 is the y value, 1 is the x value, 0 for my y-intercept. Y is equal to 3x with a y-intercept of 0. There's the slope of my tangent line at the point 1, 3, and tangent to the curve x cubed plus 2, y equals 3x. Let's graph that. Pull up the GeoGebra. We already have our previous graph uploaded. Change this to an x cubed plus 2. My new point A will slide down to 1, 3. And right here we have our equation. Y equals 3x minus virtually 0 equal to what we come up with. Good estimate. Example 3, find an equation for the tangent to the curve at a given point, then graph the curve and tangent together. Still using the same definition of slope, we will take the curve and calculate the slope at this point. Slope is equal to, the limit is h goes to 0. So here I've set up the limit as h goes to 0. Okay, next, to keep from expanding this mess here, let's go ahead and plug in the -1 for a here and here, and that'll make expanding those parentheses quite a bit easier. If I go ahead and distribute this negative sign, make the 5 positive, all still over. So now it's h minus 2 squared minus -2 squared. Since my 5 and my 5 have canceled, let's go ahead and expand this one. H squared minus 4h plus 4. -2 squared is positive 4. Negative comes down minus 4 over h. Let's cancel the 4 minus 4. Let's factor the h to the front. H minus 4. We've pulled this h out to the front. We'll cancel it here. Substitute in 0 for my h, and the slope is equal to 0 minus 4. Slope of the tangent, -4. Equation of the tangent, y is equal to -4x plus b at point -1, -1. We will substitute in a -1 and a -1, get -5 for b. Final answer, y is equal to -4x minus 5. The slope of my tangent, got its y-intercept, got the equation. Let's turn to GeoGebra now and graph it and see how close -4x minus 5 comes to our estimate. Want to look at point A when it is -1. The equation rounds off to -4x minus 5. What we had. You guys are doing good. That's awesome.